All right, so what's 4 to the third?
64.
64. So x equals 64. Good. Let's do let's do 4 then. Let's do number 4. What's my base?
10.
Yeah, if it's not written, what's the base?
10.
10. What's the exponent? Everyone write it in. Then what's the answer? Write that in, and then find it. Use your calculator, or however you want to do it. You can write as a fraction, or you can use your calculator. I don't care. Okay, whatever you get?
0.001.
Alex, what'd you get?
1 over 1,000.
1 over 1,000, and Eric got 0.001. Those are the same thing. Either one's fine.
How do you do it when you're get the fraction?
He said this is a negative exponent, so it's divide by. So it's 1 over 10 to the third. 10 to the third is 1,000. That's what he did. Because a negative exponent, remember that means you divide by instead?
Yeah, divide 3 times 3 times 3, right?
No, 10 times 10 times 10.
Oh, 10 times 10 times 10.
This tells you how many you multiply.
Oh, okay.
This tells you what you multiply.
Oh, I got you.
Yeah, that's your base. The base is what you're multiplying. Okay. There might be some okay, do you want to do y? Maybe we should do y over here. Let's try y. So what's my base? What's my exponent? What's the answer? Write it out. We have our base, we have our exponent, we have our answer. So 5 to the raised to the 1.8 is what? Natalia?
18.11.
18.1. Okay, equals 3y. And then next we're going to divide both sides by 3. And we'll get y equals, I have no idea, 6.03, I guess.
Yeah, I got 04 because I rounded it different.
Okay.
At the first step, yeah.
Okay,
18.12.
so 6.03 or 6.04, something like that, in
Yeah.
that range. Okay. All right, so then we have some that are slightly different. So, here's a quick comment. See how this one says equals? Ever look up? This is going to screw people up. If you want to, just write an x there, and then solve for x. Does that seem reasonable?
Oh, yeah.
Right. So when it has equals, if you get lost and you're like, so okay, what's my exponent? What's my base? What's my base?
10.
10. What's my exponent? We don't know. You can just put x if you want. Is everybody understanding that? What is it? What's my answer?
-4.
No. 10 to the -4. I'm not saying what x is. I mean, yeah. What's the quote answer of the part of the rewriting it as an exponential? So yes, you're right, but you're jumping ahead of what I want to do. Okay. So my quote answer is this. 10 to the -4. Does everyone understand that or not?
No.
Right. My base raised to my exponent equals this, my answer. 10 to the x equals -4, so then what's x? What's x have to be? -4.
Nice exponent answer. So this one's different, it's taken the whole?
No,
Like,
it's not.
not just the exponent.
It's always the whole. It's whatever this is always the answer. Always. Always.
Okay.
Now, if you want, you can first rewrite this. If you wanted to, you could first rewrite this and say, oh, anytime I have an exponent up there, it's really, what? I can move this in the front. So I could say -4. I should do it in a different color. Do it in black or purple. -4 log 10 equals, you could do it that way, right?
Oh,
And log 10 of 10 is just 1. So this is 1. Log 10 of 10. And so this is just -4.
-4 equals x?
Yeah, so this is a little bit tricky, because you have this, if you did it like this, then first you have to do a step of saying, well, this is log 10 of 10 is equal to x divided by -4. That gets a little bit tricky. So I would just, I would just do it this way. This is so much easier. Right? Unless you realize that this is 1. I mean, you'll get there. It just, then you have to go, okay, log 10 equals x over -4, and then 10 to the x over -4 equals equals 10. So this must be 1. So then you have x over -4 equals 1. And then you multiply both sides by -4 to get x equals -4. That's just a lot harder. And I think this is a lot more straightforward. Just grabbing it and putting it there. It's way, way easier. Unless, of course, you realize that this is 1, in which case you get there in one step as well. All right, so this is testing all your properties of logs. All right, so I think let's do 6, 7, and 8. So 6, first you gotta get the log by itself. So see how it's -5, and it's multiplied by 3. Everyone see that on the first one?
Mm-hmm.
You gotta get rid of those. So you've gotta, first get rid of, what do I get rid of first? The subtraction or the multiplication? Subtracting 5 or multiply by 3? Subtraction. So you have to add 5 to both sides. And then, and then divide by 3. Yeah. So in general, you want to solve the logs in this one by changing them to exponentials, and in general you want to solve the exponentials by changing to logs. Okay, so let's take a look what we've got here. So first we are adding 5 to both sides. And people ended up with 3 log 8 of x equals 4. And then we need to get the log by itself, so we divided both sides by 3. And then you ended up with log 8x space 8x equals 4/3, right?
Mm.
All right, so now we need to rewrite this in exponential form. So what's my base? What's my base?
8
What's my exponent?
4/3.
4/3. That's my answer.
X.
X. So I need to do 8 raised to the 4/3. You can either do that in your calculator, 8 raised to the 4/3, or a lot of you folks found this as 1.333. That's fine too. Just do 8 raised to the 1.333. What'd you get?
15.999.
What?
15.999.
Do a couple extra decimals in there.
16.
Yep. And you can also think of it as this as 8 to the 1/3 to the 4th. 8 to the 1/3, what's the cube root of 8? 2 to the 4th, which is 16. But you can also totally do it with your calculator.
So you just round up?
No, you don't round
16?
up.
So I got 15.999.
Or 8 raised to the 1.3, just do like 5 3s.
Yes, I did, 5 threes.
You do 5 3s and it still gives you that?
Yeah, 15.9998891.
Okay, well, then round to the nearest hundredth.
Oh, so just round.
Yeah.
Okay.
You gotta round at some point to the nearest hundredth, you end up with
16.
16, yeah.
Okay.
Round to the nearest hundredth, you got 16.00. Okay, so now we're gonna try, so those are the logs. Now we have these other ones that are not logs. Look at 7 and 8. 7 and 8, these are not logs. Everyone see that?
No.
These are exponents. But, yeah, David?
No, never mind.
Yeah, when you round it to the nearest hundredth, it should be 16. Okay, so number 7, that's not a log, it's an exponent. But what's up with it as an exponent? See, so I'm trying to figure out what x is. If you have an exponential like that, we're trying to figure out what x is. I can't solve by normal methods when I have x in the exponent. So what do I need to do? What did we learn that in order to use our nifty trick? We did what?
You move the X over and then
Yeah,
log
you
both
want
sides?
to be able to move the x in front, right?
Yeah.
You can only do that if it's a log. So you have to take the log of both sides.
Yeah.
So when you have this sort of problem, that's when you take that's what we did a bunch of those we did like 4 of them last class. You take the log of both sides. So remember that?
Mm-hmm.
Here, I'll do a different one so you folks can practice on that one first. 4.7x equals 13. Let me show you. I'm just going to give you folks an example. I'm going to take the log of both sides. Log of this equals log of 13. I'll write this. 4.7x equals 13. Okay. So then, the great thing about it is that it allows me to grab this guy and put him in front. Right? So now I have x times log of 4.7 equals log of 13. And the beauty of that is log of 4.7 and log of 13 are just numbers. I can find them in my calculator. Log of 4.7 x times 0.672098 equals log of 13. 1.11394. And I can just divide both sides by 0.672098. And I'll end up getting x equals, divide by 1.657. Done. So you folks now work on 7 and 8. go with that first one. The first one, 7, I'm going to take the log of both sides. So log of 3.2 to the x equals log of 8. That's going to allow me to grab him and put him in front. So now I can say that x times log of 3.2 is equal to log of 8. And I said find the log of 3.2. What's the log of 3.2? Anybody find it?
Yes, 0.505149.
505. What was it? What was the rest of it?
149. I didn't carry that all the way, I only did the 6 digits, but
149 is great. Log of 8.
it's 0.903089.
09 actually, because that rounds. Okay, yeah. So then I'm going to divide both sides by 0.50515. And you should have gotten x equals 1.788 if you round. Okay, who got that? Nobody got that? 2 people got that? 3 people got that?
Yeah, that's
What, people got
pretty
that?
much, I got it.
Okay. If you
7,
didn't get
7.
that, then check with your neighbors around you. So again, if you got that, put your hands up. Okay. Check with your neighbors around you. And then number 8, first you got to get rid of this, right? And then this, the 4x will come in front, so don't forget that.
Oh, that's right, okay.
Let's take a look at this one.
I don't know if I can.
So first thing you're going to do is you're going to add 3 to both sides, right? And you're going to end up getting 2.4 to the 4x equals 18. Now I need to get rid of this log, so I need to take the log of both sides. So I'm going to do log of 2.4 to the 4x equals log of 18. That allows me to grab him and move it in front. So now I have 4x times log 2.4 equals log of 18. Those are just numbers. 4 times x times what's log of 2.4? What's going to help me out here?
0.380211. I don't know.
Okay. And log of 18 is 1.255. So now I'm going to divide both sides by 0.3802. And that will give me 4x equals 3.30, 3.302, I guess. Divide both sides by 4. And I'll get x equals 0.825. Is that what I else got? Okay, great. So let's move on to these last 2. The last one. Right? So this is kind of a crucial one. You may very well get something like this in your exam. So what's my base?
10.
10. What's my exponent?
X.
X. Oh, everybody with me? What's my exponent? What's my base? If there's no base written, the base is 10.
10.
What's my exponent?
X.
X. If you're not, hey, everyone look up. If you're not sure if it says equals, just put an X there. Okay? So 10, what's my exponent?
X.
Ryan, what's my exponent?
X.
Great. Shania, what's my answer? No, not, what's my answer? What's this thing here? That's what I'm asking for. Remember, base, exponent, answer. So when we write this in exponential form, whatever is in front of a log, that's my answer. What's my answer? 1 over 100. So 10 to the what power is 1 over 100? If you're not sure, try a couple. It should be negative, right? So 10 to the what power is 100?
2.
2.
So
So 10 to the negative 2 would be 1 over 100. Does that make sense for folks?
So x equals negative 2.
So x equals negative 2. Yep. X to the second equals 100. So x to the negative 2 equals 1 over 100. Oh, sorry, 10. My bad. 10 to the second equals 100. 10 to the negative 2 equals 1 over 100. So x is negative 2. There we go. Okay. Oh yeah, this is important. We haven't done any of this in a long time. Shift to graph 3 right and down 2. So this is our basic one. Remember what's going on with these is whenever you have the 1 over the x problem, that's our basic problem. Eyes here. You have a center. Your center is where, eyes still here, Ryan, is where your asymptotes cross. Right, Shania? So as I shift this, wherever my new center is where the asymptotes cross. You do that first, you're in good shape. You don't do that, big trouble. So figure out where you want that center to shift, and remember that's your center is an open circle. That's not one of your points. It's where the asymptotes cross. So here, if I want to shift this, say I shifted it 2 left, I'm going to do 2 left and up 1. I'd go here, I'd go 2 left, up 1. That would be my empty circle. That's where my asymptotes go. Does everyone see what I mean?
Mm-hmm.
So if I do that, my new function would be, so what's my new function? Well, 2 left, up 1. Left is on the inside, left, right is on the inside or outside?
Inside.
Inside. So I'm going to do different. I'm going to do left. So on the inside, y equals 1 over inside x. And remember on the inside it's the opposite. So left means plus 2. And then up, down is on the outside. So on the outside of the function, I'm going to do what? Plus 1. What's my domain and range? Well, what can x not be? Look at my picture. X can't be 2. Y can't be what? Y can't be 1. If I asked you for asymptotes, the asymptotes would be at x equals 2 and y equals 1. Okay, so you do yours.
Oh, I thought we were just
So this I did a different one. I did left, 2 left and up 1. Yours is different.
Oh, okay. I thought you wanted us to cross it out
Nope.
and just do that.
No. You do yours.
Okay.
This is yours.